keep you locked in this room for a few weeks and tell you about Electricity Northwest. We're not going to do that. We're just going to try to give you a couple of bite-sized chunks, as Chris has touched on. I'll give you some of the kind of headline, big picture stuff about where we sit in, where we fit as part of the UK and the Northwest's transition to net zero. And then Joe's going to step into a bit more of the detail around some of the challenges to low carbon technologies. So yeah, that's what I've just said. So we'll just start here really quickly. This is quite a helpful way to set the scene, really. So the big mission, if you like, the big global mission is to limit global warming to 1.5 degrees, as we know, as restated in Glasgow in November last year, COP26. When we were at Glasgow last year, you'll have seen these sorts of figures. So we're aiming for this 1.5 degrees. We've already got 1.2 degrees of warming. And based on the plans and policies and commitments that national governments have put on the table, we're on the way to anywhere up to 3.6 degrees of warming. So the picture as of November last year, not particularly rosy. But where there is a little glimmer of good news is this is a bit of work that an organisation called Climate Action Tracker do, and they do a review of national net zero or carbon reduction strategies to work out whether or not they're in line with that 1.5 degree goal. So the UK finds itself, I'm pleased to say, in this box over here, in this 8% of countries that have got a strategy which is deemed acceptable. So that's reasonably good news. And you'll be familiar with a load of this stuff. This could probably fill about 50 slides on its own, but headlines in terms of the UK's net zero strategy, committing to get to net zero by 2050, 68% reduction in emissions by 2030. So those are some of the big headlines. Transport perspective, electrification plays a really significant role there. So no internal combustion cars or vans to be sold after 2030, and then a complete ban on internal combustion vehicles of all sorts by 2040. So that's the transport chunk. Buildings and heating, government have pinned their buildings and heating strategy on three key technologies from a heating perspective: heat pumps, heat networks, and potentially hydrogen. And we're awaiting a strategic decision, as government have called it, on whether to what degree hydrogen will play a role in the decarbonisation, particularly of domestic heating. And there's a load of stuff out, there's a load of reports out on pretty much a daily basis debating what the role of hydrogen will be. But as we sit here today, hydrogen will play a role in domestic heating. We've got a couple of headlines there in terms of commercial landlords and domestic properties, EPC ratings of B and C for each of them. And effectively what government is saying is we're going to introduce a load of carrots and sticks. In the meantime, it's carrot territory. It's all about incentives, it's grants and financial incentives to get you on your way. But if, as a landlord, if you've not got your properties up to a standard of B by 2030, we'll start hitting you over the head with some sticks. So 2030 is kind of got this grace period over the next 8 years to get things lined up from that perspective. And then the bit that underpins both the decarbonisation of transport and particularly heating is the decarbonisation of the power sector. So fully decarbonised power sector by 2035 is this government's commitment. And you'll see from the Labour Party conference today that 2030 has just been put into the mix. So we'll see what sort of impact that has on as this government goes through its net zero strategy review. So
what proportion of properties are at EPC ban now?
Good question. Don't know, but I suspect it'll be a relatively small proportion.
Yeah.
So you've got 80 is the until recently was the kind of required level. Certainly in domestic, I'm not as close to that, the commercial piece, but yeah, it'll be a relatively small proportion. So let's just start to translate that into what does that actually look like in more practical terms in the Northwest. Probably not the prettiest slide to show you, but the next couple of slides are some excerpts from one of our documents, the distribution future electricity scenarios. So that's basically one of our key planning documents where we take a boatload of different inputs, national policy, local policy, planned projects, market trends, etc., and say, right, what does that do for the local electricity network? We churn out 5 different scenarios. These 4 for starters. These are the same 4 scenarios that any other distribution network operator will produce. So we all follow the same methodology to come up with these. So steady progression, which you can essentially ignore, doesn't get us to net zero ever, never mind by 2050. System transformation, which is essentially big top-down interventions, so big role for hydrogen there, decarbonising, heating, and industry. Consumer transformation, which is includes a lot more kind of bottom-up, as I would describe it, a lot more societal change and behaviour change, where people of their own volition are choosing to adopt low-carbon technologies. And then so the scenario, this leading the way one, where you pull all of the policy levers at the national and local level, and you also see really high levels of societal and behavioural change. And that'll get you to net zero at some time before 2050. We also, in addition to that, those 4 scenarios produce something called best view. So we are interested in what the picture looks like out to 2050, but as a DNO, we've got to put in place investment plans for the next 5-year period and start planning up to around about 10 years. So best view is a scenario that we've got real confidence in over the next 10 years. And I'll show you what that looks like on the next couple of slides. So first one here is future trends in annual electricity consumption. So you'll see there's a fair bit of divergence as you step into the 2030s, 2040s and out to 2050. This is best view, this one in the middle, which is kind of, the average of the 2 extremes. Like I say, that does include a fairly significant amount of hydrogen for the decarbonisation of heat, which is in line with current national government strategy. But what I would say is you can almost cut off that 20-year period, and where we're trying to get people focused right now is on this next 10 years, on this next 8 years, which is, we could have some really interesting academic debates about what happens in 2030, 2040, 2050, but all of that is predicated on stuff happening right now. So you'll hear me talk a bit more about that as we go through these slides. Same picture again on EVs, really close alignment in all the scenarios there, a little bit of few discrepancies as you get out towards the 2040s and 2050s, but if you ignore this steady progression trend, which is where basically you won't see strong implementation of national local policy, will just allow uptake to go with the grain of the market. If you ignore that, we are expecting a really significant uptake in electric vehicles. So 1.2 million EVs on the northwest roads by 2030. That's up from 1 million, which is what we forecast when we did this work in the 2020 version of this document. We're currently preparing the 2022 version of it. I suspect that number will be even higher again.
Remind me, hybrids go out when?
We'll pick that up on the next slide.
2035.
35, is it?
Yeah, right. So there you go. So again, you can largely ignore this steady progression line. This is where essentially there won't really be any implementation of national or local government policy on this. We'll just let people get on with what they want to do. These really are the 3 scenarios to follow, including that best view one. So there you go, there's that 2035 date where sales of plug-in hybrids will be and no longer be allowed. Yeah. Again, the next 8 years though, there's really close alignment between 4 of those scenarios. So we're strongly pushing plug-in hybrids where that's the most appropriate choice for people, alongside pure battery. We think those are the right technologies for people to be adopting right now from a transport perspective. And I think the last couple of these graphs before we move into something a little bit different. So again, domestic heat pumps. This is largely predicated on the government's strategic decision, as they call it, on hydrogen in 2026. So what role will hydrogen play in the decarbonisation of domestic heating? If it's a significant role for hydrogen, we'll see much lower penetration of domestic heat pumps as per these three scenarios at the bottom. If hydrogen plays much less of a role, you'll see a much quicker uptake, a much more significant uptake of heat pumps. Kind of obvious, but that explains the discrepancy there. The reason there's a little bit of a lag between these two scenarios is that, as I said before, leading the way is where you pull all the policy levers and you get a really positive uptake from society and members of the public and businesses who just want to get on with this. So there's a little bit of difference between those the two upper end scenarios, but they get you to the same point.
Yeah, is that almost making that transition from EVCP to retrofit, where it's a bit more of a challenge?
That is built into the scenarios. The reason we've showed a bit of a lag is just to recognise that policy will play a really strong role there. So you've still got the 600,000 heat pumps per year is the current government target. But as ever, and the reason we rerun these forecasts every year is that government policy is changing literally every day, actually, at the moment, as you well know yourselves. So that's the domestic heat pump side of things. Pretty similar picture on the next one, which is non-domestic. Same narrative, basically. And that's all predicated on the government's decision around hydrogen, which we'll get in 2026. And obviously, even then, there's a bit of a lag. You can't expect significant supplies of hydrogen to just be switched on in 2026. There's already some really significant projects to generate hydrogen across the northwest, where Parkwest support a number of them. One at Trafford Park, in Greater Manchester, another one up at Barrow, Joe, you've been involved in. But yeah,
There's one close to Stanwell, isn't there?
Yeah.
Elton.
Yeah, and that one's slightly outside of our patch. So that's one of our
right, okay.
other DNOs, Scottish Power Energy Networks, who will be supporting that one.
Yeah.
Yeah, but you are starting to see those kind of projects come forward. There's really good confidence in hydrogen from an industrial decarbonisation point of view, which is why you'll find them in the sorts of locations we've just been talking about. But yeah, the big question is what's the role for hydrogen in domestic heating and some of the kind of commercial, the non-industrial commercial stuff.
Are we talking about hydrogen that mixes with gas or hydrogen?
And it's 100% hydrogen.
100%.
Well, it's both, isn't it? That's what's in the government's hydrogen strategy. So you've got Cadent, who we work closely with, who's kind of the gas version of us for the northwest. They've got hydrogen village trials running at the moment to test. From a kind of technical perspective, can you get a village to run off hydrogen? But also from a kind of customer perspective, are they happy with it as a vector, basically?
Just some of these projects that are ongoing with these hydrogen, what they're doing, they're finding large industrial customers that use a lot of gas. And one of these particular projects I'm involved with, they're in the process of changing the boilers. So what they're doing, they're getting new boilers that have they have gas burners and hydrogen burners. So the idea is the cost is not much different. When they're replacing all the boilers, they're going to put the new boilers in, they'll run off the gas mains, and then in the not too distant future, hopefully this electrolysis plant will be adjacent to the site, and 100% of the hydrogen that they produce will be fed into this factory. So them actual boilers will run off 100% hydrogen. And then the idea is in the future, if it's all successful and they can overproduce and they can store, etc., can they then feed into the network, and it's on a 20-80% mix and things like that.
Okay, next one. I think we've only got a couple more of these graphs to work through. So this is looking at domestic PV. So you've got reasonably good levels of PV across our patch already. We forecast, according to the best view scenario, another third capacity from PV between now and 2025. So we think that's one of the technologies, particularly with electricity prices where they are, it's just a no-brainer. You'll talk to some folk who are doing PV projects with 4 and 5 year paybacks now. So PV is good to go, and a doubling in the generation from PV by 2030. So that's on the up, and that again, that consumer transformation scenario, that orangey one, the top of the graph there, that's where people really go for it. and behaviour change really runs away with PV. And the next one is non-domestic PV. So I think, again, as I keep saying, you can largely ignore that steady progression scenario. That's where basically there's a fairly gentle amble along the route towards net zero, but all the other scenarios will show a significant adoption of PV. You talk to any business that's trying to get PV installer at the minute, or you talk to any PV installer, and that kind of uptick really resonates. Really significant interest in people adopting PV at the moment for obvious reasons. And then I'm almost certain this is the last graph to show you before we move into something a little bit different. So talked largely about generation up to now, talked about decarbonisation of transport. The other key part of the jigsaw for us is flexibility. So people are used to just being able to flick a switch and get what they want at any time of the day. And as you will well know, the important role that flexibility plays is that it enables us to tap into renewables, in particular at times when they may or may not be available. So we incentivise people to use their electricity in a more flexible way through what we call flexible services contracts, which you'll probably be familiar with. So we may pay somebody to shift their energy intensive processes to the middle of the night when there's a plethora of renewables from things like wind in particular. Equally, we might ask people to spill some generation onto the network at a certain time of the day where there's a constraint. But really the big headline message here is that we've currently got relatively low levels of flexible services being provided in our patch, but that increases significantly as of now. So the last tender we did in spring of this year, we were out to procure 33,000 megawatt hours of flexibility. That is going to be 220,000 megawatt hours when we get into 2028, which isn't a significant amount of time away. So much more flexible use and generation of electricity starts to play a really significant role as of now. And that's really key to enabling you to create the capacity you need for the adoption of heat pumps and EVs. Otherwise, the networks really struggle to keep pace with that kind of the level of uptake that we're forecasting.
So how much headroom does that give you if you can maximise flexible services where people have got a surplus at certain times and then that can be shifted to peak times?
I mean, it depends on the location. It's probably not a kind of network-wise answer to that. When we go out and do the procurement of flexible services, we focus on the areas where there's a particular constraint.
Okay.
So if you're not in a flexible service area,
Yeah.
no issue at the minute. If you are in a flexible service area, there's some capacity issues.
Okay.
Things like our heat maps tool on our website as well will give you.
Is there a direct correlation with those areas and the areas that have got most PV, or is it not that simple?
Good question. Don't know. That's the honest answer to that one.
You
It's
might go
probably
down-
not the only
Down the
factor.
route of there's not much PV in this rural location, we need to incentivise more in this area, but everyone's going for it.
Yeah, it's likely to be one of a number of factors, but I couldn't tell you exactly what goes into one particular area being constrained and whatnot. But we do have all that detail in our the DFES document and various network development plan, our flexible services documents, all that stuff, and we can send you links to all of that.
Does that connect with other DNOs as well? So if you've got particular high generation in one region and constraints in another, that you can just transfer electrons from one DNO to another. Send it to Scotland.
It's probably not that simple.
I give you that.
I think, yeah, no, just to.
Just the sentiment of being able to look at it as a whole
Help
system.
each other out, yeah.
Yeah.
It's, I mean, yes, you would look at it, but normally the constraints are localised through feeders, transformers.
Substations,
So to pass it on to another DNO, we would have to go through multiple voltage levels and transformers, which are the restrictions in the first place. Not, so to get it away is actually trying to overcome the restriction in the
So it needs
first
to be
place.
National Grid level.
Well, National Grid have their they'll have their areas of concern and looking at, and I mean the thing is with National Grid, they don't really have customers. we are
Yeah.
National Grid's customers. So we all the 14 DNOs that are now owned by 6 or 7 people are the National Grid's customers. So and that's why this sort of DSO transition has come along, that we're, you know, the sort of contracts used to be at National Grid level, and they're now coming down to our level.
Well, there's a lot of debate at the minute around how do you create a market for flexibility that enables all the different actors, National Grids, ESO, and the DNOs to work together in a nice joined up way. So we're moving in that direction. Exactly what it looks like TBC, we're moving in that direction. So that hopefully just kind of gives you a few headlines in terms of what a net zero northwest starts to look like. Basically, lots more renewable generation, as you'd expect, lots more electric vehicles on the roads, a certain level of heat pumps, TBC, lots of energy efficiency, and lots more flexible use and generation of energy. I don't think there's any surprises in there, but that's certainly what comes out of our forecasting. So what this slide is just trying to give you a nice neat summary of is saving you the job of reading now a 200-page business plan. Do read it, and I highly recommend it. It is a fine document, but if you're short on time, the headline commitment that we've made is to lead the Northwest to net zero over the next 5-year period and beyond. That commitment is based on the conversations that we have with our customers and stakeholders. So that's not something that we as ENWL alone think is a great idea. That whole business plan is underpinned by the conversations that we've been having with customers and stakeholders for the last 2 or 3 years. And that's a key test from Ofgem. You're doing what your customers ask you to do. So that's where that headline commitment comes from. And in order to achieve it, we're essentially going to do 3 headline things. Got this enabling role to play, which is basically sorting out the network, which is the non-negotiable thing you've got to do as a DNO if you want a license from Ofgem to operate. Make sure your network has got the capacity and reliability your customers would and should expect. Second thing is lead by example. So get your own house in order, become an exemplar net zero business so you can demonstrate to others what that actually looks like, what's entailed. And then thirdly, which is a relatively new thing for us, and only ourselves and one of the DNO are really in this space at the minute, is providing much more practical advice and guidance to your customers to help them do their bit, to help them adopt low carbon technologies. And we split that kind of support service into 3 key chunks. Business chunk, which I lead, domestic customer piece, and then thirdly, a support programme for community and local energy groups.
Are Western Power there the fat cats of the
They've got the biggest area.
you know, they
And Western Power actually now part of National Grid, so that's old slide.
I think they were the first to actually buy. They were the first to own. Like I said, years ago it was 14 DNOs, and I think Western Power was the first one to own 2, and I think they own, is it 3 or 4?
3, I think.
3.
Which is now, like I say, part of National Grid as of, I think, last week.
Right.
Yeah. So yeah, don't think I need to talk to you in any more detail about what DNOs are up to. But the thing that's been occupying us over the last 2 or 3 years is getting our business plans in place for the next 5-year period. That's currently in the Ofgem sausage machine, and that will pop out in December of this year through what's called their final determinations. So I've got a slide for each of those 3 things I've just given you an overview of. So what are we up to in terms of ensuring the capacity has got the network that our customers need? So we'll be spending 141 million quid over the next 5 years on what we call load related expenditure. We go through a really intense process to make sure that's at the lowest cost to customers. So are we providing the capacity customers need at the lowest cost to them? The answer to that we think is absolutely yes. If you're a domestic customer in our patch, about £90 of your domestic electricity bill will come to ENW at the moment. In our next period, that will come down to about £80. So I think we're the cheapest of all the DNOs, or will and certainly will be for the next 5-year period in terms of the proportion of your electricity bill that comes to us. But we also factor in a significant amount of uncertainty. So if any bit of our region moves more quickly through market uptake, local policy, whatever the reason, the cost of technology drops off a cliff. We've also factored in up to between 570 million and 1.1 billion, sorry, of uncertainty, which we can access through what are called uncertainty allowances. So it's 141 million in the kind of baseline plan, as we call it, but with the potential to invest a lot more if the region moves more quickly over the next 5 years. What else to say on here? And again, the key point to make is that the way we provide capacity is through a combination of physical infrastructure, more copper, more wires, etc., but also this flexible services piece. And the flexible services is what enables us to keep costs much lower. Really quick one on what we're up to lead by example. I won't walk you through the work streams on the left-hand side, but big headline here is that we're signed up to the Science Based Target Initiative. So the action that we take to become a net zero business is in line with international best practice. So we've adopted the 1.5 degree scenario as well, which is the most ambitious of all the options out there. And I think the last one from me is just a quick heads up in terms of what the business support service looks like, which I'm responsible for. Do 5 things: explain to business customers what technologies are available to them. We'll explain to them the grants and financial incentives they can potentially tap into. We'll provide them with some relevant case studies, do a combination of what we've done as a business, but also others we've supported across the region. We'll signpost to local suppliers and installers, and we'll also signpost to other colleagues and partners who might have an additional service offering outside of my team. And the way that businesses can access that support is all available on the website. Come along to one of our events, or you can pick up the phone and drop us an email, and we're more than happy to come out and talk to businesses on a one-to-one basis. And I think that's the last one from me, Joe.
Yeah.
Here we go.
Thank you.
So, big picture, high-level scene setter. Hopefully some of that's kind of familiar to you. Just hopefully starts to paint a picture of what the net zero Northwest looks like as of right now. Not some point in the future, but right now.
Thank you very much.
Thanks, Jonny. I knew you wouldn't let me down. That wasn't 10 minutes, was it?
That's the questions.
Yeah. So I'm Joe Davies. My job title is Low Carbon Engagement Engineer, and I always feel like I have to explain this. So I've been with the company 20 years as a design engineer, and then about 12 months, 18 months ago, this was a brand new position. Really, just with the journey that we're on to go to net zero. My sort of role is to engage with every single one of our customers who are looking to decarbonise, to go net zero, and the idea is that I will hopefully smooth the way to what they want to achieve and how they do it through Electricity Northwest. So one of the biggest sort of hurdles, challenges that customers say they face is the application process. Now, up until a few years ago, we did, every application was for demand. Embedded generation was few and far between. Low carbon technology was not really spoken about or heard of. Power quality assessments for new connections was not really, 1 in 50 would have a power quality issue. Now, pretty much every application we're getting through the door is inverter driven, so you've got harmonic emission currents, or the bigger like heat pumps or compressors, so we've got flicker to do, etc., etc. So I've got a set of slides which I'm just going to run through an application process. I've called it EV charge points because I think I did this for somebody else, but it does actually cover heat pumps. The application form is an ENA application form, and it covers both heat pumps and EV chargers. So just going over the different charges that we get the applications for. And again, this causes quite a bit of confusion with people and applicants and engineers alike, to be honest with you. But we have, the AC input AC output chargers, otherwise known as trickle chargers. Typically they're between 4 and 22 kilowatts. However, if you've got a 22 kilowatt charger and you've got a car with a 4 kilowatt inverter, you're only going to get 4 kilowatts out of it. But they don't have any AC DC conversion in the chargers. The AC DC conversion is in the car. So for us to actually carry out an assessment is near on impossible because we don't know which cars are going to be connected. So we just do thermal and voltage assessments for them sort of chargers. So then the AC DC chargers, these are the ones that have caused us a few challenges, let's say. We've had lots of people coming along with these. Typically they're greater than 30 kilowatts. And the challenge is we've got a double-edged sword because we are at Electricity Northwest, as other DNOs, I'm sure we are striving to install low carbon technology, create encourage electric vehicles and electric chargers, etc. But also we have to adhere to the current regulations. In this case, it's G5. Recently updated to G55. A lot of people know it's G54. There's a few changes I'll talk about in a minute. So this is the application form, and like I say, I know it's small and not, but the ENA have tried to make this as simple as possible, and I know this sort of 5-10 page document with all the, but there are a lot of these that are only applicable to certain things. So, I'm not going to sort of read through it. This was just, to give you a bit of an insight of what you need to do when you start applying for these. And what I'm trying to emphasise here is there's a few points that I'm going to point out in a minute, that if you know that the equipment is or does adhere with certain standards, it's quite an easy process. It's actually a notification, not an application in some points. So it really is critical that you know what the equipment is or the standards that it adheres to. So again, this just goes through. Again, I would say to anybody who's submitting these applications for EVs, heat pumps or whatever, actually just reading these couple of pages on the front cover could save massive amounts of time. So I can't emphasise that enough. Go on to the next, Jonny. Yeah. So again, like these, so this is the sort of notification criteria. There's heat pumps, EV chargers, vehicle to grid. As long as you can tick yes to these boxes, you can actually just install that charger or heat pump and then send us the notification. You don't have to wait. Again, we get feedback from our customers that sometimes it takes too long for an application to come back. If some of these are more the domestic level, but knowing the information can mean it's a notification, not an application.
Has there always been a requirement to register?
To register. Yeah.
Because I think a lot of the installers would have done it historically, but has that always been a requirement?
It's always been I mean, all these installers are accredited.
Everything from 7 kilowatts and up.
Yeah. We need to know, all DNOs need to know where the equipment is. I'm not going to stand here and say I'm sure there's equipment been installed and we don't know about it.
In many ways, it's just a big extension lead, isn't it?
Yeah.
So
it's more. It's like I say, it's the power quality issues that we need to look out for. So I'm not saying that we would at Electricity Northwest we brought a policy bulletin in a few years ago that we will fund all reinforcement work associated with low carbon technology connections for domestic properties. So as long as it's a domestic property, not non-commercial, and there is a little bit of justification if you've got a terraced house and you put in a 50 kilowatt heat pump in, the heat pump has to be gauged, the heat output has to be gauged for the house. So if you can justifiably say, we need this 45 kilowatts of output because it's quite a large house, and we may need to upgrade you to a 3-phase supply, we will do that free of charge. And if there's then also any upstream reinforcement work required, we will carry out that work. So but to go back to your question, whether it's whether it's PV, whether it's heat pumps, whether it's EV chargers, there has always been, again, there's notification and application, but there has been
3.68 connection is just
but you still should be notifying us of because, like I say, this document that I'm going to sort of very briefly, because it's again, if you want an early night, you can read this if you want to, but there's just a few points in this that I'd like to point out. Again, it's knowing the equipment and the standards that it can save you. When we talk about putting an application in and waiting for the DNO to come back with an approval or a quotation, you can, your life can be made easier by knowing the equipment rating and standards that and a lot of this equipment is manufactured abroad. I would, if anybody is going into any commercial agreements with manufacturers from abroad, before you sign on the dotted line, I'd be sort of going to them and saying, can you confirm that it complies with parts of G5? Just because it complies with G5 doesn't mean it can be connected, because we have to do assessments on the grid. I'll go through one in a minute that we calculate the fault level and then we can pro-rata it, and it's a straightforward calculation and an easy calculation to do. But if you can't confirm that it's compliant with such a standard, I think if you go on, Jonny. So yeah, these. So when it was G5.4, it was a 3-stage approach. G5.5 is also a 3-stage approach, but stage 1 is broken down into 4 substages. Now, and again, you might think it makes this a little bit more complicated. The idea is it makes it easy. So if your equipment is compliant with 61000-3-2, albeit it'll have to be sort of 32 amps or below, that's a notification, connect and notify us. If it's above 60 or 32 amps but below 75 amps, is it compliant with 61000-3-12? That's also a bit of a subsection on stage 1B. I think it's got 1B1 and 1B2, but is it compliant with this standard and subject to a minimum fault level? So it's that information you'd have to provide. So if you're purchasing chargers off manufacturers, especially if you're a commercial outfit that wants to sell these, in bulk as an ongoing cause, this information is required. And like I say, it's no good just providing a 150-page document, because we'd be coming back to you saying which page is it on and which section is it in. So it goes on, and like I say, if it's over 75 amps, there's this technology type and number of phases is what's required, and I think it's, if we go on to the next one, Jonny. And again, I think, yeah. So that's just pretty much what I've said. I'm not going to read through all that. I think, rather than these are the sort of how to calculate the compliance, so I'm not going to go through everything. We can do that for you as long as you provide this information. So that's the critical bit. And this goes for heat pumps. A lot of the heat pumps are smaller. They'll only be necessarily compliant with the -3-2 or the -3-12. But so yeah, these are the calculations. Don't worry, we'll do all them for you, as long as you give us the information. And then on the next one, so this is once you start getting into the bigger stuff, you've got to sort of, again, if you're going to a manufacturer, I'd be going to that manufacturer saying, does it use an active front end converter? And the reason why this came about is when the standards, if you will, went to the manufacturers were very secretive about their technology and didn't want to release the information about their technology. So the idea was, is it an active front-end converter? Don't go into any more detail. We know we can connect 192 kVA at 10 MVA, so we can then we can do a calculation on the LV network, and basically if it's 5 MVA, then you're going to be able to connect half of that, which is 95, 96 kVA. So we pro-rata the calculation, so it's a very, very easy calculation to do, as long as you can provide this information.
How long has this been in place?
This came in, if my memory serves me correctly, G5 came in April 2020, G5.4 came in before I was born, I think it was. So it's not nothing new. This is nothing new.
It's always
But
been there.
the thing is, harmonic, we go out as a DNO, and all DNOs have to, part of G5, the background levels have to be, I think, LV below 5%, at HV below 4%. We've always had to adhere to that. So the majority of the power quality assessments have been done on the larger equipment. When these EV chargers came along, in old money, these was what people used to call as dirty load. These was problematic equipment. So this is where I said before, we've got this double-edged sword. We really want to promote low carbon technology and promote decarbonisation, but we've also still got to adhere to, if somebody phoned us up tomorrow and said, my lights keep popping and my electronic equipment keeps failing, and we went along and measured the background levels and there was a 10%, we'd have a problem. We'd have to resolve that, and that, that might mean hundreds of thousands of pounds of reinforcement work. So this is the double-edged sword that we need to, and we want to promote this equipment, but we also need to protect you as consumers for everybody's supply. So it isn't anything new, but people connecting this equipment will say they've never had to do it before, and which they probably haven't, because they've never connected this sort of equipment with this sort of the harmonic emission. And quite interestingly, the biggest problems, or the biggest causes of problems, was the lower harmonic. So your harmonic emission currents are a multiple of 50 hertz. So 2 is 100, 3 is 150, so on and so forth. 3 and 5 have always been the problematic ones on the, when these chargers came along, what we were seeing is the lower ones was the less offending currents, but the higher ones was actually worse. So I think they concentrated so much on getting these lower ones, but the higher ones was a little bit more problematic. So it's when we go out and measure background. So we have what's known as power quality recorders. For any voltage complaints, any flicker complaints, any harmonic complaints, we'll connect this power quality recorder. It measures everything. We don't set it to just measure one or the other. It'll measure everything. And over the last couple of years, for the first time, we've been seeing, higher levels of harmonic emissions or harmonics on the LV network. So it's, this is probably what, and like I say, what you're finding is people are coming along saying, I want to connect 3 or 4 of these 50 kilowatt EV chargers. And we're coming along saying, well, here's a HV point to connect. Whoa, I don't want a HV point connection. I don't want to spend 80 grand on putting a new sub in for these chargers, which commercially nobody wants to, because it makes the job unviable, financially not viable. But, equally, we need to manage this in a way. So it's just, all I wanted to get across today is from an ease of application, finding out this, and don't, we are seeing people, because basically if you don't comply with this bit here, and we have to go into a stage 1D assessment, we have to, that's the only time we need to measure the backgrounds. So I think I cover this on the next one. So the backgrounds is approximately 2.5 grand to measure, because this power quality recorder is best part of 35 grand. So we've not got too many of them in the company, not got too many people who can actually put them on. It can take up to 4 to 12 weeks because of the number of them that we've got and the number of people that are authorised to use them. There's no guarantee then it will pass with stage 1D, because if we measure the backgrounds and the backgrounds actually measure to be quite a high level, it means you're probably going to be able to connect one or none to the network. And non-compliance, you may then have to go away, do a HV supply, fit filtration. It could be quite an expensive job. So it's just, this is just getting across. So it's, yeah.
Is that only the bigger chargers?
It tends to be.
22 and above, or? It's
a mixture really, because it is, yes, to answer your question, it's the above 30 AC/DC chargers.
So if I don't have one now and I've got harmonic problems, I'm not caused by someone else.
Possibly, yeah.
But you've got to pay for it.
If you put a measurement on your supply and that was over 5% or showing over 5%. We can, the power quality recorders will tell us which direction they're flowing. So, you know, if we put a power quality recorder on, we know whether it's your equipment that's causing the problem or we know whether it's the grid that's causing the problem. So yes, if it was the grid causing the problem, we'd have to rectify it. If it was you causing the problem, we'd give you that report and say we need to have a look at what equipment you're using and do it that way.
Why would the grid be causing the problem?
Because it's other connections.
So it's just other people.
It's other people. Yeah, it's not the grid. It's the connections to the grid. So you as a customer, your interface point is basically where we put the equipment on, and we know which direction any issues are. So so if it's on this side, we know it's another customer. So we'll try and locate that other customer, and it is sometimes, you know, we may have to put this recorder on a few different points and try and find out where it's coming from. So, yeah. So that's, like I say, very. I tried to do it as brief. You know, I mean, you know, if anybody, all I'd say is early engagement is key. And I've just got a few more slides, not many, but just to give you a bit of an insight, really, of why, you know, and what we're doing. So again, so Electricity North West, we are trying to promote and facilitate low carbon technology. So the reason being is, jump on to the next. So this table here is one of our policy tables that we have. What's known as an ADMD. So an ADMD is after diversity maximum demand. I know you can't read it, but you might just have to believe me a little bit in a minute. But these are all non or gas heated properties where we use an ADMD of 1 for a non-detached, and we use 1.4 for a detached. So that might be quite surprising because it might be a very low figure. These are in kVA. So if we've got 100 property housing site, we would know that we need 100 kVA, which is not a lot for 100 houses. But this is a tried and tested, proven. You know, ENA have done lots of monitoring. We've done monitoring. You know, you can bet your bottom dollar if you go and put or read the MDIs of a substation and there's 300 houses connected to it, the maximum demand on that substation will be about between 300 and 400 kVA, and that's purely simply because the diversity factor that, you know, not all of them 300 properties will have a shower at the same time, not all of them will switch to.
Is that non-electric heating?
That's non-electric heating. But even when we get down to electric heating, so when we look at like the panel heaters, that you might have, you know, 2 kilowatt panel heaters all over the house that come on and off with thermostats, and you know the top floor flat turns theirs off because everybody else's heat is rising up to their property, and so on and so forth. Again, we only actually use 3.4, so again it's quite low for what you might think is in the properties. So on the next slide, so this is a bit of an example. So this is this is one of our asset records. We've got an existing substation here with 200 kVA, 57 customers fed off it. So we would expect to see no more than 100 kVA on that of all domestic load, because these will all be gas heated, detached and non-detached properties. So on the next one, so what we're saying is, a lot of these future demands are theoretical at the moment, but we are, you know, going back to Jonny's slides, where the demand increase is a definite, it's inevitable that it's going to happen. The diversity factor at the moment is a little bit unknown. However, we've got lots of energy suppliers now saying, you know, we'll give you an EV tariff and you'll put your EV on between 10 o'clock and 2 o'clock or 4 o'clock and 6 o'clock. I know some are looking at the minimum system demand and switching your car chargers on to try and work smarter, so it's almost a flexible connection, as we've mentioned. So there's lots of things going on, but like I said, we've changed a few things. So all our new policy, or we've changed our policies now. We used to have different size cables, and we'd taper them down as we went through. We now just use the bigger size cables for everything, any reinforcement work or new connection work that we're doing. we're putting the bigger size transformers, bigger size cables, and as I mentioned before, all reinforcement work will be triggered by Electricity North West for domestic, and I keep emphasising that it's domestic only. And like I say, but you know, one of the things, and I think I'll cover this on the next slide, you know, early engagement is massive. So if you are looking to fit a lot of low carbon technology or bring an estate off gas, you know, we work with a lot of housing associations. You know, what I wouldn't recommend is you know, that you just go and fit all this equipment and notify us, which you can do, you know, by the letter of the law you probably could do, but what you might find is the main fuses in the stubs start popping, and we'd have to come along and say we need to do some reinforcement work, and you're going to have to turn them heat pumps down or off till we finish this work. So, you know, early engagement is key. If there's anything that you know of that's coming up, please come and speak to us. We'll work with you, and we'll do what we can to. We've got lots of projects on the go that we're looking at. You know, can we overstress transformers? You know, just I think a question was asked before about, you know, putting more generation on where there's more demand required. The biggest problem with mixing generation and demand is these heat pumps will all be switched on between 4 o'clock and 10 o'clock at night in the winter months. PV's not generating too much capacity at them times, especially in the northwest of England. So yeah, we have to look at some of these worst case scenarios, which is maximum demand, minimum generation, minimum demand. It really is a juggling act to try and get it all working together. But
when you come to 2030, 2035, that's got to become even a bigger problem, isn't it, with EV vehicles?
It is, yeah, massively. I mean, we've got lots of challenges. You know, there's, you know, can we get the PV to charge the batteries? Can the batteries discharge to the cars? And effectively, almost an off-grid system that is.
I saw on your forms. I filled that form in myself. I managed to fill it in, and it was okay in the end. Yeah. But there's a vehicle to grid option on there as well. So that's potentially a game changer if you're you store it in your car 100 kilowatt hours, charge it up in the day with your PV, and then that's available for export or use.
I've not seen it massively taking off yet.
There's not many cars that can do it.
Well, I think the inverters.
3 cars, isn't it, that can do it?
I think they're about 3 times as expensive as a normal inverter, aren't they?
The actual charger itself is about 4,000 quid.
Yeah. I mean, I don't, you know, like you say, if you charge your car at night, it's great if you're not going to use it that day, but you know, you're only going to discharge it half, I think, aren't you? And just in case you do need it. You know, and realistically, how
incentives you get if someone says, "Well, here's a £1 a kilowatt hour," then you might do that.
Yeah, everything could be bought, can't it? But yeah, there's massive. You know, there's lots of things coming up in the future. You know, I think I've put here. You know, please share any smart technologies. You know, I know there are universities and housing associations and other people coming up with, you know, different smart ways of actually managing, you know, the heat pumps, the houses, etc. You know, we will be going down that route in the not too distant future. How it because like I say, I think all DNOs, even National Grid, we've built and managed the networks for the worst case scenarios. Like I say, you know, maximum generation, minimum demand, minimum generation. We can't carry on doing that, or else we'd just have substations on every corner and we've not enough room in the footpaths for the cables. So we do have to work smarter, and we are coming up with lots of ways of doing that. You know, the flexible services, as Jonny mentioned before, and other bits and bats. But yeah, the future's you know, the future's bright, and well, hopefully. But yeah, just, you know, like I say, the biggest, if the biggest message I can get across is, you know, is engagement. You know, please contact myself or Jonny, and you know, any projects that you've got coming up, and we'll engage with you. The earlier the better, and we can hopefully resolve any issues that may come up.
Thank you. Thanks very much.
All right, thank you.
said we could talk to you for weeks on end, so hopefully an hour of non-stop talking didn't seem as bad in the end.